How y'all doing? Dom back here again, and time to do some nice little magic tricks with those funky little slices you can use in Go. So slices are used fairly heavily in Go because they're basically just smart arrays, and they have some nice functionality built into them. But I'm going to show you a couple little techniques you can use to do common things you might want to do with slices, such as pin data to them, copy them, uh, filter out, insert data into an arbitrary index, stuff like that. So you'll see I have this big long line of print line statements that are commented out. We're going to uncomment them as I explain each approach, and then we're going to uncomment that line to see what the output is. So let's go to the first one. And the first one is a pin slice. And this should look fairly straightforward. We have a slice of, these are all ants by the way, of 1 through 5, and then a second one of 6 through 10. And what we want to do is append slice B to the end of slice A. And you can do that with the built-in append function like you would just singular values. But you'll see what we're using this this ellipsis syntax here. If you're used modern JavaScript, you probably already know what this basically is doing. This is basically saying this slice, I want you to unpack it into its individual values. Because the append function, the second half of its arguments is a variadic argument, I think that's how you say it, meaning it can have any number of arguments for this last part. So this will unpack the slice into this variadic argument, and then when the append function gets it, it'll be in a slice again, and it just sort of appends everything onto the end. So let's go back up to the top and get rid of the comment, and if we run this, we should see basically 1 through 10 in one slice. Oops, we run this, and there you go, you got 1 through 10 all in one slice. Cool, so next, pretty straightforward. Next one is copy slice, and you'll notice that some of these say like version 1, version 2. Some of these things have some different ways you can achieve the same goal with fairly negligible differences in between them. So this one we want to make a copy of a slice. So we have a slice A. That A is always basically the same slice in all these. I just redefined it in all of them. So we're going to make a new slice B that is a slice of ints and has the same length as A. And then we're going to use the built-in copy function to copy the contents of A into B. Now, the reason you're doing this and not, say, just setting B equals A is behind the scenes, slices are backed by just normal arrays. And if you just point B at A, sure, you'll get another slice, but it's pointing at the same underlying array. So if you were to mutate something in B, you'd inadvertently end up mutating in something in A as well. But this will create a completely new slice with completely new array backing it, therefore not making it so that when you mutate B, you inadvertently mutate A. And then we just return B. So returning B, so when we go back up top and uncomment this, we should see basically this exact same slice, but you'll notice we're not returning A, we're returning B. So if we go up here, and we'll get rid of these, and we're going to, excuse me, we're going to run this, and there you go, 1, 2, 3, 4, 5. Cool. Let's move on. Version 2 of copy. So again, we have our 1 through 5. And this syntax probably looks a little weird. What this is saying is basically I want a slice of slice A starting at 0, ending at 0 with 0 capacity. Basically meaning I want something just like A, but by default it's basically just nothing's in it. And then I'm using the ellipsis, that same ellipsis thing, to give me a new slice, but basically it's kind of like appending A into an empty slice, basically is what's happening. So this should return the same thing as the other one. Let's go back up here. Write this and run, and yep, same thing. And we're going to move forward. Version 3 is basically doing the exact same thing as version 2. It's just this different syntax to do it. It just says, make me a new slice that's empty, nothing in it, no capacity, nothing, and append into it the contents of slice A. So again, it's doing the same thing, but just kind of in a different way. And uncomment this, run it, same thing. Okay. So now we're going to get to cut. And what we want by cut is we're going to have a starting and an end index. And I basically want to remove from the slice every value that's starting at I, the first index, inclusively, and stopping at J, the second index, exclusively, because that's idiomatically how the little spread operator syntax works here with slices. Is the value on the left hand side of the spread of the slice syntax is inclusive, and the one on the right hand side is exclusive. So it would be a good practice to follow the same logic. Otherwise, it might get confusing. So what we're saying is, if you look at our slice, it says starting at 1, so the number 2, get rid of everything up to, but not including index 4. So we have 1, 2, 3, and then 4, but we're not getting rid of 4. So what we should get is 1 and 5. That's it. And what we're doing here is, you see we're doing an append, and we're using the spread operator. And I'm saying give me everything in A as its own slice from the start to I. Remember, the second half of this is exclusive, so it stops before I. And then append into this slice, which is J, which in this case would be 5, and then the rest of it, and then the spread operator, so it puts the values in there. That's might be a little confusing if you use it once, it'll probably make sense. So what we should just get here is 1 and 5. So if I go up here, we want to get rid of this, and we want to run it, and boom, 1 and 5. Basically just ripped out the middle section of the slice. So next one, we want to, oops, that's wrong. So we're going to delete a specific index out of the slice, but maintain the order. That's an important distinction, because there's another approach that also removes a value from a specific index, but does not preserve the same order in the slice. So we have our same slice we always have. And I'm saying I want to get rid of the value at index 1. And you notice we use append very heavily here with the whole like sub-slice syntax a lot. So in this new slice, that is everything going up to but not including I, and then I want to put in it everything starting at I plus 1, and then everything past that, and then spread operator to give me the values. So what it's saying is, okay, give me everything up to but not including 1. So the first part of this gives you 1. And it's saying the second half of this is give me everything at 1, I plus 1, and then the rest of it. So it skips this one and gives you 3, 4, and 5. So what you should get is we'll get a new slice back with 1, 3, 4, 5. No 2. The 2 has been removed. So if you're going to go up here and run this, and 1, 3, 4, 5. Yep. The 2 is poof. It is gone. My cat is losing her shit. Is there a bug, honey? There's probably a bug flying. Let me go to the second version of that. So this is, again, doing something similar, but this is going to look a little weird. So what this is doing is you have our slice starting at 0, give me everything up to but not including I plus, and then we're using the copy function. And the reason why we're doing this is, so the copy function, you may not know this because usually you just see copy like ran without returning an argument. Copy actually returns the number of values that was copied into the target slice. And you'll see that what it's doing is it says, okay, I want this new subslice that is from our A slice, starting at I, and then give me the rest of it. So it'd be this one right here. Yeah. So starting at I, and I want to put into it I plus 1, and then that. So basically, it basically kind of like gives you a new copy where it overwrote this with this chunk right here. It might be a little confusing. And then that would give you the number of values it gave back. And what you would give back is just 1, 3, 4, 5. It's a weird way to do it, but it's another way to do it. I happened to find that particular trick online somewhere, and I was like, I didn't even think of that. That's an interesting way to do it. And we get the same result. And then, so now we're at this interesting one that says delete no order. So this is doing something similar to the first two, but it's not preserving the order of the values in the slice. And all it's doing is, so at the index we want to delete, it's replacing the value there with the value at the end of the slice. So basically you take the value at the end of the slice and put it in the index of the value you want to get rid of, and then we use the subslice syntax to basically remove the end of the slice. So what you would get here, since the 2 is dropped, you would get 1, 5, 3, 4. I think that's the way it should be. So if I go up here, get rid of this, and we're gonna run this. Yeah, 1, 5, 3, 4. It just kind of took this and sort of switched places with it, and then got rid of the 2. Now we're going to have 2 different ways of doing filtering. So I'll just go ahead and do that, and then go down here and explain it. That's probably a little faster anyway. Okay, so filter in place. So what this will do is, I have my slice, and I have defined an anonymous function here that I'm going to be using as my like check to see whether this is good or not. And it just takes an integer and returns a boolean, and all it's doing is x greater than 2. Yeah, your filter func could be far more complicated, but I like putting these like conditionals and funcs that you can call every time. Because if this was like a function, I would probably want to like pass in the function that I want to use the filter on. And then we're having this in, and the reason we're using the in is to track where we are in our initial A slice. So what we're doing is, this one says in place. So what happens is as we go over our slice, if the value passes the conditional, we're going to put it in like the starting position, so 0, and then 1, then 2, etc., etc. And I only want to take the subslice of the values that we that passed our filter function. So basically, you're kind of like using the same slice to insert the new values, and then just take the slice away instead of like creating a whole new slice, which is something you would usually see when you do something like one of the filter kind of operation you can do on arrays in JavaScript. If that makes any sense. So we range over the slice. If x passes the condition, our slice at index n, which the first time will be 0, becomes x, and then we increment our index. Then we keep doing this until we're done, and then we return the subslice of A that's from the start to N. Again, N is non-inclusive. So if I run this, since the condition is x greater than 2, what we should get is just 3, 4, 5. So let's run it. 3, 4, 5. Haha, there we go. If I go to new slice, this is basically doing the same thing, but all it's doing is it's creating a whole new slice. And then if it passes the filter function, it's appending that value into the new slice and then returning the new slice. And to make it easier to tell which one was which, I gave this one the opposite condition, which is x is less than or equal to 2. So when I run this one should just have 1 and 2 in it. Let me go up here, get rid of this, and run you 1, 2. There you go. We have filter in place and filter into a new slice. So now we're going to do insert. You want to insert a value into an arbitrary index in your slice. So this is different than append. Append always puts at the end. You're saying, I want to insert this value into a specific spot in the slice. Oh boy, it's thunderstorm outside. Great. And the value I want to insert is 10, and then the position I want to insert it in is I. So it'd be in the second value in the slice. So we're going to use append, and the first half of this is going to be everything up to, but not including I. And then the second, we have a second append. The syntax looks real weird probably. And the first slice is going to be a new slice containing our value, and then everything from I onward. That makes any sense. So the first part of this is just saying, give me basically 1. That's it. And then it creates a new slice with the 10, and then it pins onto that slice 2, 4, 5, and then finally takes all those values and appends it into its own slice. Yeah, it's a little confusing. That's why you see a double ellipsis operator here, because it has to spread these two separate slices twice. So if that didn't make any sense, maybe you can look over it, rewatch this part, and hopefully it makes more sense. But ultimately, what we should get here is that we'll get a new slice back with 1, 10, 2, 3, 4, 5. And let me run it. 1, 10, 2, 3, 4, 5. There you go. So next one is same concept, but instead of inserting a singular value, we're inserting a slice. You could probably already guess this is literally the exact same thing, but instead of having to create a new slice with the singular value, we just pass in the slice itself. So what we should get here is, since we're inserting it into the same position, which is 1, we'll get 1, 6, 7, 8, 2, 3, 4, 5. And let me go up top so I'll actually run and run that one. 1, 6, 7, 8, 2, 3, 4, 5. There you go. We just inserted that new slice into an arbitrary position in the first slice. And next one's going to be push. You should probably know what this one is. This is a common thing to do with like a queue or a stack, which is basically just, that's technically already basically what the append function does anyway, as you notice. It's just, you take slice A, you take the value V, and you just stick V on the end of A, which is what the append function already does anyway, so that's technically already pushing. Did I have that one? Okay. So, as you saw, unless I'm being a dummy and I didn't let you all actually look at it, where is push it. So I am pushing 6. So what we should have is 1, 2, 3, 4, 5, 6. Run. There you go. 1, 2, 3, 4, 5, 6. Next one is pop. That is removing the value off the end of the slice and returning it. And as you see, that's basically just we're returning 2 values: the value that was popped off, and then the slice after the value is removed. You can do that with goes hand you the little multiple return values. So I'm returning length of A minus 1, which will give you the last value, and then I'm returning the subslice of A, which is from 0 up to but not including the last value. Makes sense? And we go back up here, and I have to uncomment 2 things here because print line doesn't like functions that have multiple return values, and I have to store them in values. So what you get here is it'll say pop the number that was removed, comma, and then the new state of the slice. Which, since this is popping, we should have the value that should have been removed is 5, and what should be left is 1, 2, 3, 4. So if we run this, we have our 5 and 1, 2, 3, 4. Next part, shift. Another term for this basically is popping off the front of the slice. But you also see this called shifting. So let me uncomment this so we can use it. And if we go down here, what is it actually doing? Shift. So as you might guess, it's very similar to pop, but the value we're returning is the very first one. So the value at index 0. And then we want everything starting at 1 and then everything past it. So we're just returning a subslice that's absent the very first value. So this should give us a printf statement that says shift :1 because that's the first value, and then the slice should say 2, 3, 4, 5. And if we run this, 1 and 2, 3, 4, 5. And the last one is unshift, which is basically a push, but for the front of the slice. So we're putting a value in the very front of it. This would be more analogous to like how a stack works, where stack is first in, first out. So you're pushing on top of it. So we have I am pushing in this 0 value, and all this is an append where I create a slice that only has that value, and then append to it all the values in A through the ellipsis syntax. And what we should have is a new slice that says 0, 1, 2, 3, 4, 5. And did I comment that out yet? I don't know. Let's go back up and find out. I didn't. Okay. And we run this, and there you go. That is my slice trick tutorial that allows you to do very common things you would do with slices. One last thing I didn't mention, and I didn't have time to scrounge up the examples for this. For the cutting and the deleting examples, there's a different way you need to do those if the values that you're interacting with in the slice are pointers or structs that have pointer properties. Because of the way that slices are implemented, when you copy something away from, the garbage collector cannot properly clean up pointer references. So you have to, like, let's say that in the, I guess I could probably give you an example. Let me go to delete. So instead of just saying, I just want this subslice minus this one part, you would basically have to do something where that value that you're getting rid of, you need to explicitly set it to nil. Because if not, there's going to be like this hanging pointer reference and it won't get garbage collected properly. I should have found the examples prior to this, but I was running out of time for this, honestly. Same thing with the cutting and the deleting with no order. Just keep that in mind. If you just Google search this, it'd probably come up first couple of results. That's all I got for you today. If you liked the video, be sure to share it and follow or subscribe whatever the vernacular is for wherever you're watching this. And with that said, yeah, y'all come on back now, and I'll see you next time.